Today we're going to be reviewing for the Chapter 8 test. Question 1. Find the cross product of V and W. So remember, we always start by making our matrix. And so we have -5, 4, -8, and 6, -2, 6. And so we have to rewrite it so that we have the matrix 4, -8, -2, 6 for I, minus -5, -8, 6, 6, 4, J, and then we add for K, which would be -5, 4, and 6, -2, and that's for K. That's our last number. So we find the determinant between these two. So 4 times 6 is 24 minus a positive 16. So 24 minus 16 would be 8. So I'm going to have 8I. Well, if you look right here, the only answer that has 8I is going to be C. And so I can be done. If I want to check my answers, I could. -5 times 6 is -30. 6 times -8 would be -48. So -30 minus a -48 would be 18. And then it's minus, so it would be minus 18J. And look, I bet the last one will be minus 14K. Number 2, find the measure of the angle between the vectors of A, -15, 4, and B, 3, 10. So we said if you're looking for your angle, cosine of theta over the dot product of A dot B all over the magnitude of A times the magnitude of B. So we need to find the dot product first of AB. Okay, so remember the dot product then is going to be -15 times 3 plus 4 times 10. Okay, so -15 times 3 is -45, plus 40 is going to be -5, over, and then to find the magnitude of A, remember we squared both of those and added them together. So 15 squared is 225, plus 4 squared is 16, so 225 plus 16 is the square root of 241. Then for B, it's going to be 3 squared plus 10 squared, so that's going to be 9 plus 100, which is 109, so square root of 109. Okay? Now I can just put this into my calculator, since cosine of theta has to be equal to this amount right here. I do the inverse cosine of both sides. Inverse cosine of both sides. And so I do inverse cosine of -5 divided by, in my calculator parentheses, square root of 241 times 109, and I end up getting 91.8 degrees. Number 3, a cruise ship's path is represented by the vector 8, -2. Then it follows a new path represented by the vector -2, -8. What is the resultant path? So what we're asked to find is the path between the two of them. So essentially we're just going tip to tail in that. So to find that, I simply just have to add the two vectors. So 8 plus -2 is 6. -2 plus -8 is -10. So the resultant vector is C. Through 6, -10. Now we go to number 4. A force, F1 of 6 newtons, is pulls due north. Okay? 6 newtons. And then one pulls directly east at 8 newtons. So if I added these two, this would be the vector positive would be 0, 6, and then this one would be the vector 8, 0. If I add them together, I get the vector 8, 6. So what we need to do then is use that to find our magnitude. Remember, the magnitude of our vector is just the square root of 8 squared plus 6 squared. 8 squared is 64, 6 squared is 36, and together is 100. Square root of 100 is 10. Okay? So far I've eliminated B and D. So now to figure out my angle, I think back to one of my formulas that tangent of theta is B over A. So that means tangent of our angle is going to be equal to, well, B is 6 and A is 8. So 6 over 8. and I do tangent inverse of that, okay, and so the tangent inverse of 6 divided by 8 is 36.9 degrees. So the correct answer is C. It has a magnitude of 10 and an angle of 36.9 degrees. Number 5. Write the letter for the correct answer in the blank at the right. Find the vertical component V with a magnitude of 6.1 inches and a direction of 55 degrees. So we have to remember that we had magnitude of our vector, cosine of theta, that was my x component, and magnitude of our vector, sine of theta. And so we just plug in the numbers we know. So that's going to be 6.1 cosine 55 and 6.1 sine of 55. Okay, so I put those into my calculator. Well, and I only need to actually find the vertical component. So this would be the horizontal. That's the vertical component. So this is the one we need to find. So you do 6.1 sine of 55 degrees. And I get 4.996, which rounds to 5 inches. So A is the correct answer for that one. So now for number 6, we need to find the area of the parallelogram with adjacent sides. So this is our three-dimensional vectors. So remember, the way we did that is we found the cross products. And so we got 6, negative 8, negative 31, and 53, 7, 2. And so I'll write it out as negative 8, negative 31, 7, 2, and that is for I, minus 6, negative 31, 53, 2, and that's for J. Then I add 6, negative 8, 53, 7, and that's for K. So I find my cross product, and I find my determinant, so negative 16 minus negative 31 times 7. So that's 201i. Okay. And then 6 times 2 is 12 minus negative 31 times 53, which would be minus 1,655j. And then my k is going to be 42 minus negative 8 times 53, which would be plus 466k. And so then to find the magnitude of that, I simply square all of those numbers. I square all of these numbers, and then add them together and take the square root of that. So 201 squared plus 1,655 squared plus 466 squared. Square root of that number is 1,731.1 approximately. And so the closest one to that would be A. Number 7, 2r minus x. So we need to find what 2r is. Well, r right here is negative 372. So 2r is going to be negative 6, 14, 4. And then I'm going to subtract 6, negative 3, 5 from it. And so what I end up getting is negative 6 minus 6 is negative 12. 14 minus a negative 3 is 17. 4 minus 5 is negative 1. So the correct answer then would be B. Find each dot product, then determine if the vectors are orthogonal. So remember, how we find dot product is we simply multiply 4 times negative 7 plus negative 2 times negative 2 plus negative 2 times 4. Okay? So I'd get negative 28 plus 4 plus negative 8. I get negative 32. So if it's negative 32, it would not be orthogonal, because for it to be orthogonal, you need the dot product to equal 0. So now in number 9, they want us to find the unit vector u with the same direction as v. So first, to find that, we need to find the magnitude of v. And so we took -3 squared plus -6 squared. We squared those, so it's 9 plus 36 would be the square root of 45. And so then I took both v components over square root of 45. So that's going to be -3 over the square root of 45. And then it would be -6 over the square root of 45. And what we could do is we could check our answers to see which one of those is the exact same. Obviously it's not going to be B, but we can check between A, C, and D. And when we simplify or compare with our calculator, we find that D is the exact same. Number 10, the projection of U onto V. So remember, the projection of U onto V was the dot product of U and V over the magnitude of V squared, all of that times vector V. So first we have to find the dot product. So when we're finding the dot product, we took 3 times 9 plus -12 times 2. Okay, so all of that, 3 times 9 is 27, plus a -24, so that'd be 3 over magnitude of V squared. Okay, so that would be 81 plus 4 would be 85. Square root of 85, so that would be over 85. Then times our vector V, which is 9, 2. Okay, so we get 3 times 9, 27 over 85. And 3 times 2 is 6 over 85. A is the correct answer for that one. Number 11, you would need a ruler and a protractor for, so we will skip that one at this time. Number 12, find the measure of the angle between U and V. So remember, our formula would be cosine of theta is the dot product between U and V all over the magnitude of U times the magnitude of V. So first we need to find the dot product. And so that again was -3 times -4 plus -2 times 3 plus 0 times 1. Okay, so that would be -3 times -4 would be 12 plus -6, which would be 6, over, and then the magnitude of U would be this squared plus this squared plus this squared, the square root of it. So it would be the square root of 9 plus 4 is 13 plus 1 is 14 times the square root of that squared, and that squared. So 16 and 9 would be 25, which is just 5. Okay, and then since we know that the cosine of theta equals this, we can do the inverse cosine of that, and I put it right into my calculator. And I find it to be 71.3 degrees.